and welcome to SISYA class. This is your master physics teacher Nadeem Hafeez. As you know that in the previous class we studied about the equivalent resistance, and in this class we are going to study about the difference between the series and the parallel connection. After studying the difference between these two, we will also be doing one question. Okay, so without any further delay, let us start the session. As you already know that I am your physics master teacher Nadeem Hafeez. I have done BTech in civil engineering and I have over 5 years of experience in teaching students both online as well as offline. Okay, so let us start our today's class. As I said that we will be studying the difference between series and the parallel connections. We will take differences one by one, okay, because I want you to know them thoroughly. Okay, so let us see. Difference number one says that the components in the series connection are connected end to end. Yeah, as I already said in the previous class, that here components are connected end to end. Yeah, like this. For example, now components can be anything. It can be cell, it can be resistor, okay, or capacitors. Yeah. So this is R1 resistance and this is R2. They are connected end to end. So for example, R1 has 2 points, point A and point and B. Then R2 has two, point B and point C. As you can see that there is only one point which is common, that is point B between R1 and R2. Okay, the other points are different. What happens in the parallel connection? Components are connected across the common points. So both of these resistors will be having the same points like this. Okay. If this is R1, this is R2. Yeah. Now you can see both R1 and R2 have common points A and B. AB is the endpoint of what? R1 and AB is the point of R2 as well. So they have the common points. This is the difference number one you can write. What's the difference number two? In series connection, same current flows through all the components. Okay. So if I have the components like this, okay, then I have got the second component like this, and you can take the third component as well. Okay. If current flowing through this resistance R1, R2, and R3, if current flowing through R1 is I, current flowing through R2 will also be I, and current flowing through R3 will also be I. So the current will be same in all the resistors here, in all the components. What happens in the parallel connection? Yes, current gets divided. Okay, current gets divided like this. So if this is R1 and this is R2, current I is coming, so it will get divided into two, I1 and I2. So now there is the point to be noted here. If these resistors are of same resistance, okay, we have got the same resistance, for example 10 ohms, 10 ohms, then this current will be divided equally. Okay, but if there is a different resistance, then the current will not be divided equally. Okay, somewhere the resistance which will be lower, through that current will be higher. Okay, that we will see in the question itself. You got it? The current is divided in this parallel connection. Let us move to the next point of difference. In series connection, voltage is divided among the components. You see the difference? In series, current was same, but voltage will be divided. Okay, so if I say that, yeah, this is R1 and this is R2. Okay, voltage potential difference across R1 is V1. Okay, and potential difference across R2 is V2. So as you can see that, you can see there is the difference. Okay, here it is V1, there it is V2. Okay, but what happens in the parallel connection? It remains same. It remains same. Okay, see, that is why I am taking these differences, one difference on one slide, such that I can make it each and every time. Okay, so this is R1 and this is R2. As you can see that the points are common here, so the potential difference will also be common. Okay, so whatever happens to the current, the reverse happens to the voltage. Okay, in parallel current was different but voltage will be same. Okay, very good. Now, this we studied in the last class itself, that if we have got n number of resistors and they are connected in the series, what will be the equivalent resistance? Very good. It will be the sum of these resistances simply. Okay, so R1 plus R2 plus R3. Okay, and it's very evident that the resistance will increase when the resistors are connected in the series connection. Got it? And let's move to the parallel. The total resistance decreases. Why? Because you are taking the reciprocal of this resistance. Okay. So if I give you three resistors, I tell you I have a circuit, I need to increase the resistance of the circuit. How will you connect these three resistors? Obviously, you will connect them in the series because here resistance increases. Okay. Resistance increases. And if I tell you I need to decrease the resistance of the circuit, how will you connect these three resistors? You will say, sir, I will connect them in the parallel because here resistance decreases. I've already mentioned it here. Got it? Very good. Let's move to the next slide. Here, the bulbs get dimmer in the series connection. Why? Because the voltage is divided. You see, if you are giving the 200 volts, okay, this is how the bulbs are represented. Okay, this is bulb number 1, bulb number 2, bulb number 3. Okay, as you can see, voltage is divided. This is V1, this is V2, and this is V3. Got it? So when the voltage is divided, voltage gets dropped, these bulbs they get dimmer. Okay, now let's see the parallel. There we can see the brighter bulbs. Why? Because the voltage for every bulb will be same. Got it? Yeah, like this. See, the voltage is same because the points are same here, okay, for both the bulbs. Now let's move to the next difference. In series, if one component fails, the entire circuit stops breaking because it opens the circuit. Yeah, there is the open circuit now, so the current cannot flow. So that is why these components they will stop working. Okay, like this. Okay, let me make it like this such that I can break it later. Yeah, look. Now, for example, these three bulbs, they are connected in the series. Yeah. Now the current is coming. Okay. Now, due to some reasons, we just, the circuit has been broken. Then what will happen to these two bulbs? Obviously, they will also stop working. Yes. Very good. But in case of parallel, connection, if one component breaks, the other will start working. The other will, not stop. They will continue to work like this. If I have got it like this, okay, like this, yeah. Now, for example, the one bulb fails like this, okay, but the current through the other bulbs that will still be the same, okay, that will not change. Okay, current through these will still flow. Okay, current through these will still flow, so they will be working. Okay, they will still be working, right? So if one component fails in the parallel, the rest will continue to work. Got it? Very good. So that was the difference between the series and parallel connections. Yeah, I hope you understood it. If you have any doubts, write in the comment. Okay. Now let's do one question. Okay. The question says that for the series parallel arrangement shown below, find the circuit has been given. Okay, the arrangement has been given. We are being told that we need to find three things. What are the three things? First, the supply current, that is the current flowing through this. Yeah, current flowing through each resistor, current flowing through 2.5, current flowing through 6, 2 and 4 ohm resistors. Okay, and then the third, potential difference across each resistor. Got it? So we will start with the first one, the supply current one. Okay, let us see. Now, the voltage, the potential difference which has been given is 200 volts. Got it? Okay, let us try to solve it. It's very easy. Okay, it's very easy. You will see this. Tell me, this 6 ohm resistor and this 2 ohm, they are connected in the parallel. Okay, so I can solve them. Yes. So what is the formula for equivalent resistance when they are connected in the parallel? 1 by R equivalent equal to 1 by R1. R1 is 6 plus 1 by R2. R2 is 2. Good. What is the LCM of 2 and 6? It is 6. Very good. And 6 divided by 6 is 1 plus 6 divided by 2 is 3. Got it? So 1 divided by R equivalent will be equal to 1 plus 3 is 4 divided by 6. So it comes like this: 2, 2, 4, 2, 3, 6. Yeah. So 2 divided by 3. Now I take the reciprocal of this and it will be R equivalent equals to 3 divided by 2 ohms, that is 1.5 ohm. Got it? So instead of these two resistors, I can use only one resistor which will be of 1.5 ohm resistance. Got it? Yeah. I hope you are getting it. So now let me make the circuit. This will be 2.5 ohm. Then you have one more, that is 1.5 ohm. Okay, very good. Then we have another one, that is 4 ohm. Now tell me, these three resistors are connected in the series. Okay, so if I need to find the equivalent resistance of these three, how will I find it? It is very easy. When they are connected in the series, so their resistance is just sum of these three. Okay, so R1 plus R2 plus R3. What is R1? It is 2.5. What is R2? It is 1.5. So 2 plus 1 is 3 and zero point 0.5 and zero point 0.5 is 4. 4 plus 4 is 8. So R equivalent is, I will write it here, 2.5 plus 1.5 plus 4. So it will be equal to 8 ohms. So instead of these three, I can write only one. Okay, I can keep only one resistor, but its resistance should be 8 ohms. And what is the potential difference? It is 200 volts. Okay, so if I know the potential difference, if I know the equivalent resistance, net resistance, can't I find I? Yes, I can, using Ohm's law. Okay, so I would say using Ohm's law. What is Ohm's law? Yes, yes, Ohm's law says that V equals to I into R. Okay, where V is the potential difference, I is the current, and R is the resistance. Okay, so using this, I will be equal to V divided by R. Got it? What is V equal to? It is 200, yes. And what R? It is 8. Okay, so 8, 216, yeah, then 8, 5, 40. So I is 25 amperes. So the net current which is flowing through this is 25 ampere. So part number 1 done. The net current, the supply current is 25 amperes. Okay, very good. So if we are done with the part number 1, let us move to the part number 2. Okay, what is the part number 2 saying? It is saying that current flowing through each resistor. Okay, very good. Now we see this 25 ampere is flowing. So that means this 25 ampere is flowing through the 2.5 ohm resistance. So we got it. So current, okay, let me name this as I1 and let me name this as I2. Okay. Now if the resistances would have been same, it would have been very easy. For example, this 6 and this is 2, they are different. Okay. So I need to find this I1 and I need to find this I2. I will tell you a trick. Okay, using that trick, it will be very easy for you to find the current through these two resistors. Let us see. Let me first find current through 6 ohm. Okay, is equal to, what is it equal to? I have kept it as I1. Okay, first you write the opposite resistance. Now we are finding the current through 6 ohm. Then what is the opposite resistance? 2 ohm. So I will write that 2 divided by, I will take the sum of these two resistors which are in the parallel, that is 6 and 2, 6 plus 2, okay, multiplied by the total current which is coming, which is getting divided. And what is that? That is 25. Yeah, we already calculated it. So it's equal to 2 divided by 6 plus 2 is 8 into 25. Okay. So 2 1 2 4 8, and here it's 4 6 24, and it remains 0.25. So the current flowing through 6 ohm resistance is 6.25 amperes. Okay, very good. Now we need to find the current through 2 ohm resistance. Now it will be simple. What is the total current coming? What is the total current coming? It is 25. How much current is flowing through 6? It is 6.25. Now the rest, whatever remains, that means 25 minus 6.25, that will flow through 2. But I will still use this formula, okay, such that you can get hold of this. Current through, just watch very carefully, through 2 ohm resistance will be equal to, I need to take the opposite resistance, okay, that is 6 divided by sum of two resistances, that means 2 plus 6, that will still be 8, multiplied by 25. Okay, it will be 6 divided by 8 multiplied by 25. Got it? Okay, so just simplify it. 2 3 6, 2 4 8. Okay, so you know that 25 divided by 4 is how much? We just calculated here, it is 6.25 multiplied by 3. How much is it equal to? 0.75. Okay, 18.75 amperes. Got it? So current through 6 ohm is 6.25 and current through 2 ohm is 18.75. Now when these two will sum, it will be 25 again. Yeah. So current through, yes, how much? 4 ohm will be equal to 25 amperes because it will be sum. Got it? All right. Let's move to the next, slide. And now we need to find the third part. What is the third part? Potential difference across each resistors. It is easy, guys. See, current flowing through this is 25. Okay, current flowing through this is 6.25. Current flowing through this is 18.75, and current flowing through this is again 25. Okay, very good. Now I need to find the potential difference across each resistor. Let us see. See part number 1. Okay, now I need to find the V1 here. Okay, V1 equals to I1 R1. Got it? Very good. V1 equals to, what is R1 equal to? 25. Yeah. What is I1 equal to? 25. What is R1 equal to? It is 2.5. Got it? So V1 is equal to, we just need to multiply it. 25 into 2 is how much? 50. Yeah. And then 50 and 50 plus, you just need to take half of this. That means 12.5. Okay. It will be equal to 62.5 volts. Okay. So potential difference across this is 62.5 volts. Then V2. Okay. Let's see potential difference across this 6 ohm resistance. Okay. Very good. So it will be I2 R2. Yeah. What will it will be equal to? Again, what is I2? It is 6.25. Yeah. Multiplied by, what is R2? It is 6. Got it? How much will this be equal to? It will be equal to 37.5 volts. Got it? Now potential difference across two will also be same because they are connected in the parallel. Yes, but still let us prove it. Okay, V2 will be equal to, and there will be difference. Let me name this as V3, I3, R3. Okay, fine, sir. What is I3? It is 18.75. Yeah. What is R3? It is 2. Got it? So now when we multiply it, it comes out to be 37.5 volts. Isn't it same? Yes, because they are connected in the parallel. So now let's see. V4, yeah, 25. I'll name it. No worries. What is I4? It is 25. What is R4? It is 4. So 25 into 4 is 100 volts. Okay. So now you found the potential difference across this resistor, and across this resistor as well. Okay. And you know that if you want to check it still, the total potential difference will be equal to V1 plus V2 plus V3. What is V1 equal to? It is 62.5. Yeah. What is V2? It is 37.5. And what is V3? It is 100. You see, 62.5 plus 37.5, it is 100 plus 100, okay, which gives you total of 200 volts. That is true. You know, what was the potential difference which was given to you? 200 volts. This 200 volt got split into three, okay, 62.5, 37.5, and 100 volts, okay. Now you need to tell me, is there any way, is there any other method in finding this potential difference across 6 and 2? If yes, tell me in the comments, okay. Now let me give you the homework. Homework tells you that you have this circuit. You need to calculate the current through 3 ohm resistance. Okay. 3 ohm resistance, you need to find the current flowing through this. And the potential difference here is also 200 volts. Got it? I hope you understood it. If there are any doubts, okay, just tell me in the comment box. Have a very, very good day. Bye bye.